So on Friday, we went through and we colored. You don't need that. Yeah, if you picked up the worksheet, will you put it back? That's so sorry. If you want to know what to do, it usually tells you on the board. Pull out your coloring key features worksheet and pick up colored pencils if you didn't finish. So, on Friday, we went through and we colored all of these. Pull out your worksheets, please. Yeah. Where's your worksheet? Pull it out. Okay, so today's kind of tough because for some reason students have trouble differentiating between x-axis and y-axis. Everything we do today will be x-axis except two items, the range and the y-intercept. So on these graphs, everything is x-axis except range and y-intercept. So for this first graph, it looks like this. Okay. And we colored domain, range, and everything else. Now we're going to describe the domain and describe the range. Okay? So when you colored the domain, hey James, you're going to have to put those away if you can't listen. So you should have colored the entire x-axis because every part of the x-axis is represented on the graph somewhere. Where would -8 be represented? Somewhere really high. Okay? So, if what you're describing, oh, that was nice, is the entire axis, the answer is just all real numbers. And instead of writing all real numbers, we're lazy. So we write a symbol. It's an R with a double bar on the left. Yes, I would write this, as this is part of your assignment. Okay? That means all real numbers. Just like this means all natural numbers, and this means all whole numbers. So it's every number on the line is part of the graph. Yes? Yeah, this is number 1. This is the first of the 4 number 1s. Yeah, that's just domain. Decide with your name on it. I don't know why the computer numbered these and it numbered them all as 1. I don't understand why that happened. Yeah, they're all number 1. Okay. Now the range. In order to fill out the rest of this, we need to know the minimum or maximum point. We need to know the x-intercepts and the y-intercepts. So if you have a calculator, pull it out. If you don't have one, you're in serious trouble. What's that? You got your calculator? Okay. So type in the equation and push graph. Okay. Hang on. Okay, you can go in a minute. All right. Then I push graph. Okay. First, I need to know either the lowest point or the highest point. Does this have a minimum or a maximum? Minimum. So push second, calc. Number 3 is minimum. Now it's going to ask us 3 questions. And this is x-axis. It's asking us to pick some x value to the left and some x value to the right. And then we're going to guess what we think the answer is. So what x value does it look like the minimum is created by? What's that? What x value will give us the smallest y value? How far on the x-axis do we find the minimum? No. It looks like about 1. when x equals 1, the graph is at its lowest point. Does everybody see that? When x is 1, the graph is at its lowest point. So, I need to pick, my minimum looks like it's right here. I need to pick some number to the left and some number to the right. So a number to the left might be -1. So I'm going to type in -1, enter. Oops, sorry. So -1, and then it puts a little arrow. It's kind of hard to see, but there's a little arrow up here pointing to the right. What is a number to the right of the minimum? 4 or 5 or 6, as long as you don't go off the page, you're okay. So I'll type in 4, and then you can see another arrow here. Is the minimum between those two arrows? Yes, so we're okay. Now, what x value do we think is the closest to the minimum? 1 or 2, maybe 0. I'm going to type in 1, and I get 0.7. I'm going to round that up to 0.75. So my minimum, just write this off to the side, is 0.75 comma -3.125. $3.125. No, that's the minimum. Okay? So when x is 0.75, the y value is -3.125, and that is the lowest point we can find. What would the maximum point be? Infinity. This graph never ends. It goes up to infinity. What was your question? Oh, okay. So, this helps us with the range. Okay? If we look at the y values, can we say all real numbers? No, why not? Right, how far down does this graph go? Well, right here, -3.125. Everything below that, oops, everything below this does not exist. Right? These y values are not part of the graph from there down. So, to represent that, there are two ways. Okay? What you do is you say, so range, domain is x, is all real numbers, and range is going to be y. So for the range, you can either write two less than symbols with a y in the middle, and then you put the small number on the left and the big number on the right. What is the smallest number that y can be? So -3.125. What is the biggest number that y can be? Infinity. Now we have to be careful. Can y be -3.125 exactly? Yes. So we actually need to write this as less than or equal to. Can the y value equal infinity? No, you can't get there. In fact, the more you travel toward infinity, you never get any closer. What is the distance from 1 to infinity? Infinity. What is the distance from 1 million to infinity? Infinity. So if I asked you to count to infinity, you might as well not start, because no matter how far you get, you're no closer to the end than you were when you began. That's weird, huh? Yeah, no matter how hard you try, you're never going to get there. Okay, so there's another way to write this that's a little bit easier. Okay, instead of writing the y and the inequalities, we can condense it down into this number and that number. So what we'd say is y equals -3.125 comma infinity. Just like a coordinate, just like an xy. But we have to be able to distinguish between equal to and not equal to. Okay? So, what we do is, on the equal to, we put a bracket, and on the not equal to, we put a parenthesis. And that's the way I want you to write it because it's so much easier to do. So you put the small number, comma, big number. It's always small, comma, big, and then the parentheses or brackets let you know whether it's open or closed, whether it's an open circle or a closed circle, whether it's equal to or not equal to. Okay. So now the next one is x-intercepts. Looking at this graph on my calculator, it looks like the x-intercept is at maybe -1/2 and 2. But there's a way to test it. So if you do second calc, number 2 is 0. Remember, x-intercepts are also called roots and zeros. So I'm going to push number 2. And if I want to find the one over here on the left, what is a number to the left of the answer? -2. What is a number to the right of the answer? Well, I could say 8 or 12 or something like that, but you want to make sure that you don't go past your second root. So if I want a number somewhere in here that's far enough to the left to miss the root I want, but I also don't want to go past my other root. 0 would work or 1 would work. Either one. 1. And my guess, I'm going to guess 0, and one of my answers is -0.5. So for x-intercept, one of them is x equals -0.5. Now we do the same thing for the other root. Second calc 0. If I'm trying to find the root on the right side, what would be a good left bound? One or 0 would work, so I'll put in 0. What would be a good right bound? 3, 4, 5, 6, all the way up to 10. 11 would be bad because 11 is off the page. So I'll type in 5. What should my guess be? I'll guess 2. And the answer is, in fact, 2. Okay, for the y-intercept, all we have to do is plug in 0 for x. Yes, but don't put parentheses around it. Okay? Because what does 0.5 comma 2 mean? Like this. That's a point. It's the point 0.52. That's not what we're looking for. What if I were to put parentheses around that? That's an interval, which says x is every number from -0.5 to 2. Is that true? No. So you don't put parentheses around it. What's that? Okay. For the y-intercept, let's look at the equation. If you plug 0 into the equation, what do you get? Well, if I put 0 in there, what does that do? What is 2 times 0 squared? 0. If I put 0 in there, what do I get? 0. So the answer would be -2. 0 minus 0 minus 2. So my y-intercept is -2. Okay. Now here's where it gets a little tricky. So, I want to know which x values make y values that are increasing. Okay? When we when we drew increasing, what part of the graph was increasing? Everything to the right of the minimum, which is a little bit to the right, or a little bit to the right of the axis. So this is increasing. Does anybody not understand why that's increasing and why the other one is decreasing? If we look left to right, what part of the graph is going up or down? Okay, so as we move to the right, this portion is increasing. I want to know which x values are represented on that right side, on that increasing point. What is the first x that starts to go up? Well, negative 3.25 is a y value, right? Well, if we look at the minimum, that point is where they change, right? So if I travel across the x-axis, is the graph going up or down? Down, 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 until when? Right there. What is this number? Not 1. It's 0.75. Okay? So my minimum value is negative 3.125. My minimum value is a y value. But if I want to know increasing, I'm asking which x values make the y values go up. Okay? How come a bunch of you don't have your worksheets? Where is yours? Oh, you want to go grab one? It's over in the box. Do you have one? Oh, okay. So this red line here is all of the x's where the graph is going up. Is the graph going up at negative 0.75? No, what is it doing? Is it going down at 0.75? No, it's flat. Because we're going down. When we hit the bottom, we're perfectly level. If we go a little bit more, then we're traveling up. So if I were to write the interval for increasing, what is the smallest number for increasing? 0.75. Not 0. Is it going up or down at 0? Still going down at 0. So 0.75. What is the biggest number for increasing? No, negative 3.125 is a y value. We're looking at the x's. So this number here is 0.75. When does it stop increasing? Never, so it would be infinity. So I write x equals, yeah. Yes. Yeah. So when we get to parentheses, that will work. So when you write this, x equals every number from 0.75 to infinity. But is it actually going up at 0.75? No, it's flat. So is it going to be parenthesis or bracket? So this is parentheses. Is it actually going up at infinity? Well, we can't reach infinity. They're both parentheses. Right. Okay? So when it's not going up, it must be going down. And we're going down on this portion. Where does that down portion start? Not infinity, negative infinity. So some of you aren't paying attention. You might want to... I could give you front row seats if you'd like. So if you look at this portion, the smallest number is x equals negative infinity. When does it stop going down? At 0.75. Yes, Joseph? Well, this is increasing. Now we're doing decreasing. So we're looking at the down. So over here, it's going down, 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 down until that point. So it's everything from the left side, from negative infinity, up until 0.75. Are these parentheses or brackets? Both parentheses. Okay? All right. Now we need to do positive and negative. Where is the graph positive? Above the x-axis, right? So we have two pieces that are positive. I have this piece, and I have that piece. Okay? When does the first piece start and end? The one on the left side. Not -1. Look at your x-intercepts, -0.5. So we look at our x-intercepts. The x-intercepts are the points where we switch from positive to negative or negative to positive. Right? So on this left side, so this one I'm drawing in black, what is the smallest x value for that portion? So x equals -infinity. What is the biggest number on that left portion? -0.5. Now, can we include -infinity? No. At -0.5 is the graph above the x-axis. It's on the x-axis. So it's a parenthesis. Because it's not included. It is. It's on the line. Is 0 positive? No. Positive is anything above 0. So it goes down, and once it hits, what's that? It's not negative either. You're right. 0 is not negative or positive. Yeah. It's neither. Yeah. So all numbers are not either negative or positive, because there's a 0, which is none of the above. We're answering positive. Okay? But there's another positive piece. Right. So now we're looking over here. What is the smallest x value for the portion on the right? 2. What is the biggest x value? Infinity. Is 2 included? Is the graph above the x-axis at x equals 2? No, it's on the graph. So like that, and we never include infinity. Now, we have a problem here. We have two separate groups of answers. And whenever you have two separate groups, you have to decide, is my answer the combination of the first group and the second group, or is it what the first group and second group have in common? Well, do the first group and second group have any numbers in common? No, they're on opposite ends, right? The one portion is all negative and the other portion is all positive. Well, these are called unions or intersections. Okay? A union means everything in one group and everything in the other group. Intersection means what one group and another group have in common. And whenever you have two sets like this, you have to decide, is it a union or is it an intersection? Well, this is obviously a union because they have nothing in common. The symbol for union is a big U. And the symbol for intersection is an upside down U. So whenever you have two groups, you need to put that union symbol in there. It's the union of the first group and the second group. It's like saying, in this class there are 15, well, let's not, this class, you're all sophomore, so that doesn't work. So suppose we look at another class. That's true, he's not here. So let's say that in a class we had 15 girls and 16 sophomores. Okay, the union would be every girl and every sophomore, which would be something bigger than 16, right? The intersection would be only sophomore girls. So if I said all sophomores and all sophomores union all girls, that means every sophomore and every girl is part of the group. But if I said the intersection of sophomores and girls, that group is going to be a lot smaller, and it will be only those people who are both sophomores and girls. And intersections are upside down U's, and unions are regular U's. Okay, so where is this graph positive? Or sorry, negative? Below the x-axis, so all of this stuff down here. What is the smallest number in that set? Negative 0.5. So for negative, x equals negative 0.5. What is the biggest number in that set? 2. Do we include negative 0.5? No. Do we include 2? No. And now I'm done with that first, with the first number 1. Yeah, you'll need that. Yes. Well, everything we're going to do today will be union. In fact, I don't know that we're going to do intersection ever. It'll always be union. But it's union means one group, everything in one group and everything in the other. Intersection would mean only those things that this group and this group have in common. But these don't have anything in common. So it won't happen today that you see intersection. Okay. So your homework today is going to be to finish the page, but let's go through and find the minimums and maximums and the roots, because you need the minimums and the roots in order to fill out the rest of the paper. So look at number 1-2. If I graph this, go to y equals negative x squared plus 5x plus 2. Now I need to find the maximum. So I'm going to push second calc maximum. It looks like it's about 3.5. Looks like my maximum occurs. Hey, James, you'll be marked absent if you're not in your seat, just so you know. It looks like the maximum occurs at 3.5. So my left bound, I'll pick 2. My right bound, I'll pick 4. And my guess, I'll pick 3. And it says that the maximum is at 2.5, comma 8.25. Okay. This is the second number 1. Yes. Second calc max. And then, so if I look, my graph looks like this. Well, here's my maximum, which looks like about 2.5. Right? This x value looks like it hits about 2.5, so I pick some number to the left, then I pick some number to the right, then I pick an answer that's close. Any number to the left and right will work. Yep. Yes. We're not there yet. Okay, let's find the x-intercepts and the y-intercepts. So second calc 0. What number, if I want to find this root, what is a number to the left? Three would be to the right. -1 or -3 would work. -3? What's a number to the right? 3 would work. What I want to pick like 8. Why would 8 be a bad choice? We don't want to pick a number so far to the right that we include the other root. So 2, and my guess will be 0. So one x-intercept is -3.372. For the other one, second calc 0. So if I want to find the root on the right, my left bound will be 2, my right bound will be 8, and my guess will be 6. And it says 5.37. Now look at that y. 1e to the -12. What that means is -1.0 times 10 to the -12. This is scientific notation which tells you to move the decimal 12 spaces to the left. So this is a bunch of zeros, which is a number that is so small, it's 0.0001. It's actually 0. This is the calculator trying to be smarter than it actually is. So whenever you see e to a negative number, it's just a number that's so small the calculator pretended that it was going to write it, and it's actually 0. Okay. What would the y-intercept be here? Well, look at the equation. If I plug a 0 in there and a 0 in there, what am I left with? 2. So the y-intercept is 2. And actually, this number here will always be the y-intercept every time. Okay. All right. What about the domain? All real numbers. What about the range? Well, the range ends up here, right? So how high does the range go? Well, the range reaches this number. So what is the smallest number in the set of all ranges? -infinity. What is the highest one? Do we put parentheses or brackets on the infinity? Parentheses. Parentheses or brackets on the 8.25? Bracket. Okay? So that's your homework tonight, is to do the rest of this. And that will be due tomorrow. Yes. Yeah, do the other 2 problems on the back.